In these videos, we're going to think how we can use Polaris to measure astronomical distances in the sky. In this first question, a student measures the altitude of Polaris as 38 degrees. Deduce the latitude from where the student is observing. Well, this is nice and easy as long as we know the fact that the altitude of Polaris is the equivalent to the latitude from where you're observing. So therefore, if Polaris is at 38 degrees, then the latitude is also at 38 degrees. And because we're observing Polaris, we would be in the northern hemisphere. Similarly, in the second question, a student is observing from a latitude of 73 degrees north. To the nearest degree, what will be the altitude of Polaris? We're using the same fact, but in reverse. So this time, the latitude that you're observing from is the same as the altitude of Polaris. So therefore, it will be plus 73 degrees. Again, a very similar question. Sian is observing the night sky from the Mourne Mountains in Northern Ireland, and they have a latitude of 54 degrees north. To the nearest degree, how far above her northern horizon will Sian observe Polaris? Well, again, it has exactly the same altitude as the latitude you're observing from. The height above the northern horizon will be 54 degrees. Similarly, in the South Pole, or the southern hemisphere, again we're not using Polaris here, but a similar process. An observer in Wellington in New Zealand deduces the angle between the southern celestial pole and their southern horizon is 41 degrees. To the nearest degree, what is the latitude of Wellington? Well, it's the same but the opposite in the southern hemisphere, so it'll be the same. So this will be 41 degrees, but this time south. Okay, the declination of Alpheratz is plus 29 degrees. Calculate its polar distance. So this is where we're going to use the equation that polar distance equals 90 minus the declination. So the polar distance equals 90 minus the declination, which we can see is 29. So therefore the polar distance is 61 degrees. So that's the distance between the star and Polaris. Again, we're doing the same thing here. The polar distance of Shadar is 34 degrees and 28 minutes. Calculate the declination of the star. So again, in a very similar way, we're going to use the equation that polar distance equals 90 minus the declination. But this time we've got to do a little bit more. So it's 90 minus 34 degrees and 28 minutes. So if we minus off the 34 degrees first, 90 minus 34 will give us 56, but then we also need to minus off 28 minutes, so that will leave us at 55 degrees, and 60 minus 28 leaves us 32. So the answer will be 55 degrees and 32 minutes. Musca the Fly is a small constellation at the foot of Crux, the Southern Cross. The declination of Alpha Musca is minus 69 degrees. Calculate the polar distance. So again, we're going to do exactly the same thing that we would do in the southern celestial pole. So again, it will just be 90 minus the 69. So that is going to be 21 degrees away from the pole. And finally, in our last question, a group of students were observing the stars close to Polaris. The students calculated that at their latitude, a star of declination plus 62 degrees would have an altitude of 81 degrees above the northern horizon at culmination. Deduce the latitude from where the students were observing. So firstly, we can calculate the calculate the polar distance, which would be 90 minus 62, which is 28 degrees. So that means that the star is 28 degrees away from Polaris. Now it tells us that it will have an altitude of 81 degrees above the northern horizon at culmination. So 81 degrees, we would find our star at its highest point, and we would know that Polaris, which it would be rotating around, would be 28 degrees away from it or underneath, because the star would move around. So we know therefore the height or the altitude of Polaris will be the 81 minus the 28. So 81 minus 28, which is 53 degrees. So we know therefore that Polaris must be 53 degrees. And again, because we're talking about Polaris, it will be in the northern hemisphere. And so that is our final answer. So hopefully you can mark your own and see how well you've done on those questions.